So I'm going to get started. So what we're looking at, section 9.4. So we're dealing with second degree equations. And again, if you're watching the video and you're wondering, wow, why is it like this? Our servers got knocked out on campus, and well, this is going to be doing this from home. So what we're looking at are second degree equations. And first degree, well, this is something like this. That would be a first degree equation. When we're talking about degree, we're talking about the variable. So a first degree, if you notice, our x this is x, which is x to the 1. So that's where we get the idea of first degree. We're looking at the degree or the exponent that's on the variable. Now, for second degree, it's going to be different. So what we're going to have for second, and if I'm going a little fast, let me know.
I think I got it.
All right. Well, then for the second degree, looking for the highest degree variable, the variable with the highest exponent. And that's going to be your second degree. So any questions about that? All right. So what we're going to be looking at, last time we looked at solving first degree equations. Now we're going to be looking at second degree. Now, second degree, there's two ways of doing this. And the first way assumes you know something about factoring. And factoring can get fairly complicated. So what I'm going to do, I'm going to show you the second way first. So if you look in the text in section 9.4, you're going to see them use something called the zero product principle. And that requires some knowledge of factoring. I want to show you a different method because factoring can get kind of tricky. So the other way of doing this, and this is sort of what works every single time, is what's called the quadratic formula. Now, what the quadratic formula is used for, it's for second degree equations that look like this. Now, A, B, and C, they're standing in for numbers. So this could be like a 4, a -2, and a 6. And what we're going to do, once we identify these numbers, X is going to be this. So that is how you find the value for X. And the plus or minus in this, that's going to mean there's a chance you could get two answers. And for a lot of the problems we're going to be working with, more often than not, we're going to have two answers. And we'll go over how to come up with those. And if you ever have a quadratic equation, that's what this is called. This is the formula, and this is the equation. Whenever you have a quadratic equation, you can use the quadratic formula to solve that quadratic equation. Now, any questions about that?
You're going to show us how to get from the equation to the formula, correct?
I could if you want me to. Oh, how do I put it together? Do you want to see how this is derived?
Yes.
Oh, wow. Okay. Well, that I can do. Now, how to derive this takes it's interesting. So here we go. Let's see. Now, the first thing we're going to do to derive this equation, it's kind of tricky how to do it. Now, for like the homework and things like this, for the homework, you won't have to know this. But if you want to know where this comes from, we're going to solve for x. Now, the first thing we're going to do, we'll divide both sides by a. So we'll divide each term by a, and this 0 by a. Now, 0 divided by a is just 0. So we're going to get something like this. So again, we divide each of these terms by a. Now what we're going to do, we're going to subtract c over a. We'll subtract that from both sides. And when we do that, scoot this. If I'm going too fast in any of this, let me know. We're going to get something like this. Now, the next thing we're going to do, once we get this, we've divided by a, and we subtracted c over a from both sides. We're going to do something called completing the square. So to complete the square, and this is kind of an advanced algebra trick, a little bit advanced. We're going to take this, divide it by 2, and we're going to get b over 2a. We're going to do that first. Now, this is part of that trick. Then we're going to take this, we're going to square it. And when we square something like this, and again, this might be something that's been a while since you've seen it, but this exponent, this 2, will go to the b, the 2, and the a as an exponent. So we get b squared, a squared, and 2 squared is equal to 4. So any questions about that?
No, that's good.
All right. So the next step so this is our equation so far. We're going to add that b squared over 4a squared to both sides. Now, for completing the square, what this means, you have x squared plus b over ax plus b squared over 4a squared equals, and then I'm going to put the b squared over 4a squared minus c over a. Now, on this side, this is set up to complete the square. So I'm going to make a little side note here. If we have x plus, I'm going to say n over 2 squared, this is equal to x squared plus nx plus n squared over 4. So, and again, this is kind of an advanced trick. What we're going to do is we can take this and rewrite it in this form. We're going to start with this and go backwards. So instead of n for us, n will be that fraction b over a. And so what we're going to get is we're going to get this. So again, this is kind of a tricky thing, but this will let us complete a square. We're going to get something like this.
Wow. Okay.
Now,
So I'm sorry.
oh, yeah,
I was
take
just
your time, absolutely.
double checking with you. You went and you plugged in the formula, and then as you went back, I see that we okay. So we're looking at the x plus n over 2 squared. So what we're doing there is we're taking that one and plugging it into the formula.
We're going to take this. Now, this is a formula for completing the square.
Oh, okay, like what we did before.
Well, this is a new kind of formula for this one. And again, this is kind of an advanced trick what we're doing here. But if you're completing a square, if you have something that's of this form, you can rewrite it like this. And so what we're doing is we're saying, well, this is our n, b over a. And then we have b over a, b squared, a squared. So that's the n squared. Then there's a 4.
Awesome. Okay, great.
And then that's the substitution we're making right here. So now we can take this, or in other words, this thing right here, and we can rewrite it like this, or in other words, like this. And then this is the formula we had before on the right side, which is going to be our area of interest next. But any questions about that?
Mostly I got it. I was trying to figure out, okay, so you got the X and then you got the B and then the 2A and it's squared. Okay, so then on the other side I have the B squared and the, oh, okay, I see. So then there's no need for the n x plus n over 4?
Oh no, that we
Cancels out.
won't need.
Gotcha. Okay, great.
Basically, this here, it's kind of switched is what it is. This here is these two things. And what's going to happen, because this equals that, it's going to get a little, I'm going to have a, let's see, it's going to be blue and green. This will become that because of this formula.
Okay, I think I got it.
I don't know if that helps or makes it worse, to be honest.
I can totally see how we got, okay, so how we turned the lighter blue area into x plus, and then you got the square, so x plus b over 2a squared. And the darker blue area turns into the b over a, is that what I'm looking at?
What the darker blue is going to do, it's where we identify what n is. So b over a in front of x, n in front of x. This is an n squared here.
Okay, I'm with you. I got you. Okay.
And I could probably post a supplement too, breaking this whole thing down. It would probably help if I switch these as far as sides go. But this is sort of a formula you use in somewhat advanced algebra when you're working with a way of solving these quadratic equations. And it's called completing the square. And it's interesting, but it's what they use to get the quadratic formula.
Awesome. Okay.
But I can post something. I could post a little supplement, just kind of going through maybe a better stepwise approach. I could do something like that for sure. Well, the next thing here, this is still something we have to deal with. So it comes back down here. And then, or here, maybe this will help. What's going to happen here is using that formula. Will drop down, and using that completing the square, we can rewrite this right here. I can put it like this. We can use the completing the square formula that says x squared plus nx plus n squared over 4. This will be equal to x plus n over 2 squared. So this part here we can rewrite like this. Where n for us will be b over a. And so that'll take us to the next step where this can be rewritten into a different form. X plus b over 2a squared equals b squared over 4a squared minus c over a. I don't know if that helps a little bit or not.
Okay, so when you got, okay, so I'm at the part where, okay, so you have n equals b over a,
Mhm.
and then you got, so from there we went down and we got x plus b over 2a, and then you
Mhm.
squared, okay, and then we got b squared over 4a squared minus c over a. Okay, I see where you're going with this.
Okay, wonderful. And yeah, just as kind of an algebra note, b over n over 2, which for us is b over a over 2, this will simplify to b over 2a. Now, the next part, we're going to look at this right side. We want to combine these two fractions. So what we're going to do, we'll take x plus b over 2a. This will leave the same. Now this one, we need to give it a common denominator with this. So there's an a, but we need an a squared. And we also need a 4. So what we can do is multiply the bottom and the top by 4a. And then we're going to have that common denominator. And we're going to get something like this. So now we can combine these into one term. So any questions about that? So what we're going to do next, we're going to square root both sides. And when we take square roots, it's possible that the square root of a number could be positive or negative. So what's going to happen, we're going to get a plus or minus. And that's for the positive number or for the negative. Again, if I'm going too fast, let me know. So here's our old equation. Now this time, we're going to square root it. Now you might remember from last time when we talked about first degree equations, we talked about opposites like addition and subtraction are opposites, multiplication and division are opposites. Well, squares and square roots are also opposites. So they'll cancel each other. And what we're going to get is x plus b over 2a equals, now here's a key thing, plus or minus the square root of b squared minus 4ac divided by, and this is all under the square root, 4a squared. Now, the plus or minus here, where this comes from, here, I'll make a little note. So if you take 2 and square it, you get 4. Or if you take negative 2, square that, you get 4. So what this means, if you take the square root of 4, there's 2 possible numbers. We could have squared a 2 to get 4. We could have squared a negative 2 to get 4. So positive 2 or negative 2 could be our answers there. So that's why that plus or minus is there. It's a sort of a kind of a consequence of the arithmetic. So the next thing, another algebra trick, and this one, we don't talk about this one in this class, but when you have a square root and there's a quotient underneath, that square root gets broken up. So the plus or minus for these square roots, we're just going to keep this on the top one here. So we could write it like that. And this is still could either be positive or negative. Now this here we have the positive square root, which is fine. And if this is supposed to be negative on the right side, the whole thing, that whole right side will be negative just because of that one negative. So this is all right. We don't need the plus or minus on this bottom square root. Now the square root of 4a squared well, that's 2a. We'll take the square root of 4, which is going to be 2, and the square root of a squared. Well, the square root and the square are opposite, so they'll cancel. You just have the 2a. Questions about that? So there's a couple things left to do. We'll subtract b over 2a from both sides. So b over 2a will cancel here. And these have the same denominator. So that means later we're going to be able to combine these. So any questions about that so far? Hold on one sec. Looks like having a little camera difficulty.
Did you do that on purpose?
No. The
Oh, okay,
camera's get
like, sorry.
it's a little funky. Let's see. Let me try this. Let's try and. There we go. All right, sorry about that. I have a backup camera. I'll probably have to switch over to that soon. So what this gives us, we'll have x equals plus or minus square root b squared minus 4ac divided by 2a minus b over 2a. So now we can combine these. They have the same denominator. So they'll become a single fraction. Then we could switch the order on these. We can call this and that is our formula. So it takes to get there. Now there are formulas for third degree polynomials or third degree polynomials, and those are very complicated. So if you think this one looks kind of rough, they can get a lot more tricky. But any questions about that?
No, sir.
All right. So I'm going to go through some examples. I'm just going to pick some from the text. Take a look at the homework here. And again, you don't need to know how to derive the quadratic formula, perhaps thankfully, because that's quite a chore. But I think it's one of the better ways to go, mostly because, let's see, pick one here. You have to be comfortable with the techniques of factoring to use the zero product principle. We'll go over how to use it. We will cover it. But if you're not sure, you can always use the quadratic formula. So we want something in the form ax squared plus bx plus c equals 0. We want something like this. So what we want to do, let's move this 8y squared over to the other side. And the way we do that, we can subtract 8y squared from both sides. And so when we do that, what we're going to get is 3 minus 2y minus 8y squared is equal to 0. Now again, we want it to look like this. And we can rewrite this. We could say, well, this is negative 8y squared. So it's still got a minus in front of it. This one still needs a minus, so minus 2y. But this is a positive 3. So we'll keep that 3 positive. So we just want to make sure this stays negative, this stays negative, that stays positive, negative, negative, positive. We're all right. So now we want to identify the A, the B, and the C. Well, what's in front of y squared? That's going to be that A. In this case, it's a negative 8. In front of y, that's our B. And it's also going to be negative. It'll be negative 2. So the number will take the sign with it. And then C is positive 3. So now we use x is negative b plus or minus the square root of b squared minus 4ac divided by 2 times a. And what we're going to do, we're going to replace a, b, and c with these numbers. So that's going to mean so we replace the b's minus 4 times negative 8 times 3, a negative 8 and a 3 there, a little small 3. All of that divided by 2 times negative 8. So any questions about that? So the b's we replaced with negative 2, the a's we replaced with negative 8, and c we replaced with 3. Now, if we take a look at this, this is a negative and a negative. That's going to become a positive. So, and negative 2 squared will be a positive 4. This is a double negative again. Negative and negative is a positive. And then positive and negative will be negative. So, simplifying that arithmetic. So x will be 2 plus or minus the square root of 4 plus, and we had 4, so we had -4, -8, and 3. And that's going to give us a plus 96 over -16. So -4 times -8 times 3 is a plus 96. Now we're going to work within the square root first. We got to clear this up before we do anything else. This will be 2 plus or minus the square root of 100 over -16. Now the square root of 100 is 10. So we're going to get 2 plus or minus 10 over -16. Now this is where the plus or minus comes in. We're going to get 2 answers. So the first answer, we can go with the plus. So we'll have 2 plus 10 over -16. Now 2 plus 10 is 12. And positive divided by negative, and fractions mean divide. They can also mean divide. We're just going to have a negative. And we can reduce this. This is a fraction 12 over 4. So if we divide top and bottom by 4, and since this is a positive divided by a negative, the answer will be negative. And that's just sort of a format that we use. We have a negative on the top or bottom number. If there's only one negative or just one negative here, we draw it out to the outside here. So that's one of our answers. Questions about that? And we're not done yet. So let's take a look at this plus or minus again. Now what we're going to do is consider the minus. So we look at 2 minus 10 over -16. Now 2 subtract 10, what you're going to get is -8 over -16. Now these are both negative numbers. If you divide one negative by another, they'll come out positive. Negative divided by negative is positive. And these divide top and bottom by 8. And we're going to get 1/2. So this has 2 answers, -3/4 and 1/2. And usually you put your answers in what we call set notation. You put them in these little curly braces. But this would be your solution. Questions about that? So let me do another one. Now, let's say you have something like this. Let me check my numbers here. I think that should be fine. Now, again, we want a squared or ax squared plus bx plus c is equal to 0. Now, for this one, it's a little tricky. You have an a in front of the x squared, but there's nothing in front of this x squared. When there's nothing in front of a variable, there actually is something there. It's an invisible 1. And the reason for that, this is sort of an internal note, 1 times x squared is just x squared. And 1, or in this case, this is going to be our next step, negative 1 times x is going to be equal to minus x. So because of these little arithmetic facts, what we're going to get is that a is 1, b is negative 1, and then c in this case is negative 2. So any questions about that? All right. So in this case, we have something like this. We're going to get negative 1 plus or minus square root of negative 1 squared minus 4 times 1 times negative 2. All of that, the whole thing, divided by 2 times 1. And that's going to be the setup. So any questions about that? Now, if we simplify, we'll have 1 plus or minus the square root of 1, because negative 1 squared is negative 1 times negative 1, or positive 1. Here we have a negative 4 times 1 times negative 2. That turns out to be a positive 8. Then 2 times 1 is 2. So now what we do, we'll simplify this. So taking a look here, 1 plus 8 is going to be 9. And again, if I'm going fast, let me know. There's a lot of steps here. We'll get x is 1 plus or minus the square root of 9 over 2. Or 1 plus or minus 3 over 2. So now we're going to get those two answers again. 1 plus 3 over 2, 1 minus 3 over 2. So if we do the plus, this will be 4 over 2, or just 2. Then for the minus, you'll get -1. So the answers for this problem will be -1 and 2. Questions about that? Now, there's 3 other quadratics I want to show you. And it has to do, 2 of them are special properties of the formula. Again, if I'm going too fast, let me know. But let's take a look at this formula. I'm going to make some notes here. Now, so far, b squared minus 4ac we've always gotten something bigger than 0. So when that happens, we have 2 solutions. And that's what we've been getting so far. But now, I'll do a couple examples like that reflect the next 2 points. If this equals 0, you'll get 1 solution. And if this is less than 0, then what you have are no real solutions and if you're wondering, this thing in here has a special name. It's called the discriminant. So when the discriminant is bigger than 0, like we've been getting, we're going to get 2 solutions, 2 answers. If it equals 0, we're only going to get 1 answer. If it's less than 0, we have what are called no real answers. Now, there is an answer, but it's a special kind of answer that involves imaginary numbers, or what they call complex numbers. And that we won't get into today, but it is possible to describe an answer for this kind of discriminant. So any questions about that? Is it okay if I erase this, or should I wait?
You can erase it.
Okay. Yeah, I just don't want to go too fast. So let's say we have something like this. So for this, A is 1, B is -6, and C is 9. So just for the sake of time, I'm just going to do the substitutions. So negative b plus or minus the square root of b squared minus 4 times a times c divided by 2 times a. So if we simplify things, we get 6 plus or minus the square root. Negative 6 squared is 36. Negative 4 times 1 times 9 is negative 36 over 2. Now, of course, 36 minus 36, that's going to be 0. So we get 6 plus or minus 0 over 2. And the key thing here, adding or subtracting 0 doesn't change anything. So that's just 6 over 2. And we have one answer, 3. So when this discriminant is 0, I could have said square root 0 here, because I just got a little carried away and skipped a step. Square root of 0 is 0. And the reason is if you do 0 times 0, which is 0 squared, well, you still get 0. But when that discriminant is 0, we're only going to get the one answer, and that's it. So questions about that? All right. So let me show you one where the discriminant is less than 0. Now, again, we want to get this in that special form. So we want to make sure we add 1, which is the opposite of subtracting, to both sides. So we get x squared plus x plus 1, pardon me, is equal to 0. I want identifier A, B, and C. A is 1, B is 1, and C is 1. Now, plugging that into the quadratic formula, we get x is negative b plus or minus square root of b squared minus 4 times a times c divided by 2 times a. Or negative 1 plus or minus the square root of 1 minus 4 times 1 is a minus 4. This minus here is that there. Divided by 2, or negative 1 plus or minus the square root of negative 3 divided by 2. And this is where we get a problem. This is less than 0. If we have something less than 0 in the square root, then our solution, well, proper way to put it is no real solution. Questions about that? All right. So let's take a look here. There's one more I want to show you, one type. Let's say we have this. Let's say we have this. Now again, we want to put it in standard form. So we want to subtract 4x from both sides. And we want to add 1 to both sides. Now this will cancel, this will cancel. We have 0. So now we look for A, B, and C. And again, the sign attaches to the number. We got +1. So filling in the quadratic formula, negative b plus or minus the square root of b squared minus 4ac divided by 2 times a. So simplifying this down, we'll get 4 plus or minus the square root of 16 minus 8 over 4, or 4 plus or minus the square root of 8 over 4. And this is where we have to have kind of a talk, because we're going to take the square root of 8. Now, there's 2 ways you could do this, and it depends on what the problem's asking for. The first way we're going to do it is the exact method. So this is a little bit like what we were doing with pi. This means we're going to get the square root of numbers that don't have a square root, or a square root that's, well, you're going to have square roots that are long infinite decimals. And you can either round those off for an approximate answer, or what you can do is you can keep them as exact. We're going to do the exact first. Now I'm going to show you an idea. If a times b is in a square root, you can rewrite it as square root a, square root b. So this is what we're going to do with the square root of 8. The square root of 8 is the square root of 4 times the square root of 2. So we have a times b, 4 times 2. So this says we can rewrite this as the square root of 4 times the square root of 2. Now, the trick here is we know 4 has a square root. So we want to make sure we have a number that does have a square root. Square root of 4 is 2. Now, square root of 2 has an infinite square root. So we're just going to leave it as square root 2. Just like if we have pi, we leave it as, instead of rounding it to 3.14159, we could just leave it as pi. And so we call this 2 root 2. Even there's a implied multiplication here. So you get those implied multiplications when you have variables next to each other and when you have something in front of a square root. So this is the exact answer. Now, next what we're going to do is go back up to our original problem with this exact answer. And again, if I'm going too fast, let me know. So where we left off, we have 4 plus or minus square root of 8 divided by 4. And we found out that this is equal to 4 plus or minus 2 root 2 over 4. Now, what we can do next is called factoring. 4 is 2 times 2. 2 root 2 is 2 times square root 2. And of course, the 4 down here will be 2 times 2. Now, we have a times 2 and a times 2. This looks like it was a 2 that got distributed. So if we took this 2, we distribute it here and distribute it to here, we would get this up on top. Now we can cancel. This 2 and this 2, just like reducing fractions, they'll reduce away, they'll cancel. And so what we'll get is 2 plus or minus square root 2 over 2. So again, we're going to get 2 answers. Two plus square root 2 over 2. 2 minus square root 2 over 2. And so for exact answers, what we'll have 2 minus root 2 over 2, 2 plus root 2 over 2. So those are the exact answers. And again, they're exact because this is an infinite decimal and that's an infinite decimal. We don't try to convert those or round those off. Now, let's say we want the approximate answer. So square root 2 is approximately 1.414. I'm going to use a lot of digits here. 213562. So using that fact, let's go back to this. Well, this will now approximately be over 2 . If you divide by 2, and then rounding this off, let's say to the nearest thousandths, tenths, hundredths, thousandths. Since there's a 1 here in the 10,000ths, this doesn't change because the 1 is less than 5. So that's how we can come up with one of the approximate answers. And then we got to come up with the other one, square root of 2 subtracted from 2. So that's going to be this. Oh, don't want to forget, still divided by 2. Do the subtraction, we're going to get this, divide by 2. And we're going to get this. And again, if we round to the nearest thousandths, so tenths, hundredths, thousandths, the number behind here is 5 or greater. So that means this number gets bumped up. And so that's going to be the other approximate answer. So for the approximate answers, what we're going to have are these 2 decimals. So those would be your approximate answers. So any questions about that? The last thing I want to show you is what's called the zero product principle. And if you're comfortable with factoring, this is a pretty good way to solve these. Now, sometimes there are techniques for factoring that won't work. Answers that will have a square root of 2 in it, you won't be able to factor those, at least not using the techniques they usually use in your algebra classes. But let me show you one. Let me show you how the zero product principle works. So the way this works, if A times B is equal to 0, then A equals 0 or B equals 0. Because if this is 0, well, times 0 gives you 0. If this is 0, well, it's still times 0, you get 0. If both are 0, 0 times 0 is 0. So let me do an example of this with factoring. So let's say we have this. Now, from algebra, there's a technique what you could call kind of a guess and check. But it works like this. We want to come up with two numbers, A and B. So let's not use A and B because we've been using them up here. Let's say M plus N. And then M times N. So this is the guess and check. And this is going to be the case when the lead coefficient, the number on the x squared or the r squared or the t squared, when this is an invisible 1. When you have an invisible 1 here, this technique works. You're looking for two numbers that add up to the -5, or the number that's attached to the plane x, not the x squared, but just the plane x or the plane r or the plane t. Two numbers that add up to this number that's attached and also multiply to the constant that's by itself. So in this case, two numbers that will work are -2 and -3. Or at least they do the adding part. Will they also multiply? Because these certainly add up to -5. Well, that's good news. But do they multiply to +6? We need both of these to happen. So I'll check them off. So this one so far, this is good. We're good here. Now, if it doesn't work here, you got to come up with two more numbers. But -2 times -3 is +6. So that means we can rewrite this as x minus -2 times x minus -3. Here, let me check my math here on this. Yes, okay. So in other words, and we always have the minus here. So we're going to get x plus 2, x plus 3 is going to be equal to 0. And this minus here, the x minus and the x minus, so x minus m, x minus n. For this technique, this is always going to be here. So this is where the zero product principle goes. Oh, I'm sorry, I need to scoop this up. My apologies. So we've got something like this. x minus m, x minus n. Maybe put an m and an n here. So this will always be here, that will always be there. So now we do the zero product principle. If this product, x plus 2 times x plus 3 is equal to 0, and then what that means is that x minus 2 is equal to 0, or x minus 3 is equal to 0. And then we just solve for x. Add 2 to both sides. For this one, we'll add 3 to both sides. So what we'll get, x equals 2 and x equals 3. And of course, if we put this in that set notation, squeeze this on the bottom here, it'll be 2, 3. So again, if you feel comfortable with your factoring techniques, you can use the zero product principle. If you're not comfortable with factoring, use the quadratic formula. That's perfectly fine. And let me take a look at the homework here. Yeah, they do say try it using factoring, but if you can't solve the equation using factoring, use the quadratic formula. So there's nothing that you're going to solve with factoring that you can't solve with the quadratic formula. So questions about that? All right. Well, what I could do, let's see here. Take a look at one more. Let me do one more example, and that'll be it for today. It illustrates a different type of factoring technique. Let's see here. And this one can be a little tricky. So let's say we have this. I'll do this example, and this will be last one for today. But you might remember this factoring technique. Again, these are problems you can solve using the quadratic formula. Now, again, we want this in standard form. We subtract 6 from both sides. We get 2x squared plus x minus 6 is equal to 0. So the technique I'm going to show you is called the AC method. So the other one was called guess and check, or I call it guess and check, I should say. This was often called the AC method. And so we take the a in front of the, in this case, an x squared, and then the constant c. And for the first step in this, we take a times c, which is 2 times negative 6. We get negative 12. All right. So next thing we're going to do, we're going to try to come up with two numbers. Turn that off. I think they're just asking to find what my if my car has its warranty checked. I think that's what that is. So we want to find two numbers, n1 times n2, that equals this negative 12, and we want n1 plus n2 to equal the number attached to this plane x or and this are r or t or whatever variable we're using, well, the number attached here is an invisible 1. So we can think about this, what two numbers multiply the negative 12 and add up to 1, and it turns out numbers that do that are 4 and negative 3. 4 times negative 3 is negative 12. 4 plus negative 3 is 1. So that's our second step. Now our third step is we're going to rewrite this equation is 2x squared. And now that 1 that's in front of the x, well, we rewrite that as 4 plus negative 3. And so if we distribute the x through here, what we'll get is 2x squared plus 4x minus 3x minus 6 is equal to 0. And now we're going to do a technique in algebra called grouping. Let's group these two terms. We'll group these two terms. What can we factor out of these two terms? Well, this first group, we can factor a 2 and an x. So this will become 2x, x plus 2. And again, you can check if we distribute 2x to x, we'll get 2x squared. 2x to 2, you'll get 4x. Now, what could we factor out of here? We can factor out a negative 3. And when we do that, we'll have x plus 2 left over. And again, you can check. Negative 3 times x would be negative 3x. Negative 3 times 2 would be negative 6. So next what we could do, we have an x plus 2 and an x plus 2 in two different places. We can factor this out. And again, if I'm going too fast, let me know. So there's x plus 2, and then 2x minus 3 is equal to 0. And again, if you distribute this to the 2x, you'll get that first term that we had. Distribute this to the minus 3, you'll get the minus 3 times x plus 2. So now, finally, we get to use the zero product principle. This is our A, this is our B. A times B is equal to 0. So that means x plus 2 equals 0, or 2x minus 3 equals 0. And so we solve for x. Minus 2, minus 2. So x is negative 2 is one of our answers. Add 3, add 3. 2x equals 3. Divide by 2, divide by 2, and we'll get x is equal to 3/2. So putting these answers together, what we'll have is negative 2 3 halves. And that's going to be our answer. So that's it. So again, for factoring, if you're comfortable factoring, you can use factoring in the zero product principle. Some, at least with, you have a limited number of techniques for factoring, and you might not, they're not going to necessarily, at least for the techniques taught in most algebra classes, they won't help you with factors, or if your answers have square roots in them, you might just have to use the quadratic formula for that one. If you're not comfortable with factoring, you can always use the quadratic formula for any of these problems. Factoring is just another way of doing it. So that's it for today. If you have any questions, let me know. Otherwise, have a wonderful, wonderful day.